Alright, we're going to look at your review for your solving quadratics test. This first part says choose any method to solve the following quadratics. Remember, tomorrow on your test, if you see solutions, zeros, x-intercepts, or roots, all of those mean the same thing. Now, in each one of these, I'm going to show you how to find A, B, and C so you could use the quadratic formula, but I'm also going to solve it in other methods. Okay, for instance, number one, all it has is an x squared and a constant negative 25, and it's already set equal to 0. So if you wanted to use the quadratic formula on number one, your A value would be 1. Your B value would be 0, and your C value is negative 25. Okay, because you could rewrite this as 1x squared plus 0x minus 25. Okay, you could use those three numbers in the quadratic formula. But there's a faster way to solve it. When we first started talking about quadratics, we talked about solving by taking the square root. So we wanted to isolate the x squared. In order to do that, you would add 25 to both sides of the equal sign, which gives you x squared equals 25. To get rid of the exponent 2, you take the square root of each side of the equal sign. The square root cancels the square, and you're left with x equals 5. Now, when you solve by taking the square root, as soon as you take this square root, you must write plus or minus in front of your answer so that you have two solutions. So x is positive and negative 5 is the answer to number 1. You could also get the same thing using quadratic formula. Looking at number 2. On number 2, you need to set your equation equal to 0 first. So draw a line through the equal sign. In order to set it equal to 0, I'm going to move negative 26x and negative 48. To move those, I just use the opposite sign. I would add 26x to both sides, and I would add 48 to both sides. So here's what I'm going to be left with. 3x squared plus 26x plus 48 equals 0, because none of those items will combine with each other. From here, I'm going to label A, B, and C. A is 3, B is positive 26, and C is 48. Now, once you label A, B, and C, you want to put those items into your quadratic formula. So my quadratic formula is x equals opposite b. The opposite of 26 is negative 26, plus or minus the square root of b squared. Notice I put the 26 in parentheses, minus 4 times a, so I'm going to put the 3 in parentheses, times c, so I'm going to put the 48 in parentheses, all over 2 times a. Again, there goes the 3, which is a, in parentheses. Now pause and plug it in your calculator. Remember, when you plug it in the first time through, put a plus. Then go back the next time through and put this minus. So when you solve it with the plus in there, you should get x equals negative 8 over 3, or you could have written that is negative 2.6 repeating, or negative 2.67. And when you solve it with the minus, you should get x equals negative 6. Now moving on to examples 3 and 4. Again, example 3, just like example 2, you've got to set it equal to 0. Draw a line through the equal sign. This time it equals negative 32. So to get rid of negative 32, add 32 to both sides. You'll have 5x squared plus 28x plus 32 equals 0. Again, just like last time, easiest thing to do, label A, B, and C. A's 5, B's 28, C's 32. Remember, A is in front of x squared, B is in front of x, C is the number by itself, C for constant. So from there, I would just use my quadratic formula. X equals opposite B, so I put negative 28, plus or minus the square root of B squared, so I put 28 squared, minus 4 times A, so 5 goes in parentheses, times C, 32 in parentheses, all over 2 times 8. Now pause, plug it in your calculator. First time with a plus, second time with a minus. When you plug it in with a plus, your answer is x equals negative 8 over 5, or you could write that as negative 1.6. It's exactly negative 1.6, no rounding. When you plug it in with a minus, you get x equals negative 4. Okay, moving on to example number 4. If you look at example number 4, it's already set equal to 0. Now some of you might be trying to do the x method with it, and if you tried the x method and you went 3 times 10 is 30 and b is 12, but there are no factors of 30 that will add up to 12. You got, 6 times 5, 3 times 10, 15 times 2, 30 times 1, but none of those add up to be 12. So you must have to use the quadratic formula to solve this equation. Now the good thing is it's already set equal to 0. So just label A, B, and C. A's 3, B's 12, C's 10. And then plug them in your formula. X equals opposite B, so negative 12, plus or minus the square root of B squared. So I got 12 squared minus 4 times A, A's 3, times C, which is 10. All over 2 times A, so 2 times 3. Pause, plug them in. When you plug it in with a plus, you should get x equals approximately negative 1.2. When you plug it in with a minus, x equals approximately negative 2.8. All right, let's move on to 5 and 6. When you look at 5, you could do this a couple of different ways. If you wanted to use the quadratic formula, when you look at that one, the number in front of x squared is 10, so that means A equals 10. The number in front of x is 15, so that means B equals 15. And behind this 15, there is no C value, so that means C is 0. So you could use those numbers and punch them in to the quadratic formula and solve. But you could also factor. This is a GCF problem. And if you remember our steps for finding the GCF, the first thing we did was we identified the greatest common factor. Okay? And the greatest common factor here is 5 and x. 5 will go into 10 and 15, and both of them have at least one x in common. So what we did when we found the GCF is we took it out, and we wrote it outside of a parentheses, and then we divided it out of each term. So the first term we would have 10 divided by 5. 10 divided by 5 is 2. X squared divided by x is x. You go to the next term. 15 divided by 5 is positive 3. X divided by x, in this case, these x's cancel each other out. So now we have two factors. The last step was to take each one of these factors and set them equal to 0. So 5x gets set equal to 0, and 2x plus 3 is set equal to 0. And we solve each one. To solve the first one, divide by 5. Zero divided by 5 is 0. So the first solution is x is 0. On the second one, you got a two-step equation. You would subtract 3 from both sides, and you'd bring down 2x equals negative 3 because 0 minus 3 is negative 3. To solve it, you would divide by 2. And your solution, your other solution, is x equals negative 3 over 2, which is also negative 1.5. So either way, you write that, it's fine. Now, if you look at number 6, okay, you could set it up and do quadratic formula. All right, you could do, right here we got a equals 1, b equals 11, c equals negative 50. So we'd want to take those three numbers, and we can go ahead and do that because it's set equal to 0. We want to take those, and we want to plug them in. So x equals opposite b plus or minus the square root of b squared minus 4 times a times c. Make sure when you put c in, you put a negative 50 in there, all over 2 times a. All right, you could take this time to pause and punch it in your calculator. Remember to punch it in with a plus and with a minus. All right, when you punch it in with the plus, and you convert it to a decimal, your x value is 3.5, roughly. When you go back and you punch it in with a minus, your x value is roughly negative 14.5. So again, another one that you have to use the quadratic formula for. Okay, let's move on to 7 and 8. All right, if you look at 7, 7's kind of like number 1. You could start off by setting it equal to 0, subtract 438 on both sides. And that minus 438 will combine with that minus 3, and you'd have 9x squared minus 441 equals 0. And you could label A, B, and C. A is 9, B is 0, C is negative 441. Okay? That takes a few too many steps for me. All right? I would rather solve this one by taking the square root, because all I have is an x squared. So what I can do is I can isolate this x squared and then take the square root of both sides. In order to do that, I start by adding 3 on both sides. So I should get 9x squared is equal to 441. Next, I would want to get rid of the 9, so I would divide both sides by 9, which would give me x squared equals 49. And finally, I'd want to get rid of the square, and I do that by taking the square root of each side. The square root cancels the square, leaves me with x equals 7, but since I solved by taking the square root, my answer is plus or minus 7. Remember, when you solve by taking the square root, your answer is plus or minus. When I go to number 8 has to be set equal to 0 first. So I draw my line through my equal sign. I would subtract 4x on both sides. Again, that minus 4x and 4x squared, they will not combine. I would then subtract 8 on both sides, and I would be left with 4x squared minus 4x minus 8 equals 0. Now when I look at this trinomial, I notice that each term has a greatest common factor. 4, 4, and 8 all share a GCF of 4 in common. So what I would do first is I would factor out that 4, and remember, when we take it out outside the parentheses, that means we have to divide it out. 4x squared divided by 4, what happens here is the 4's cancel and I'm left with x squared. Negative 4x divided by 4, again, the 4's cancel and I'm left with negative x. And then negative 8 divided by 4 at the end is negative 2. Now if you remember back to last week when I solved this equation, the first thing I want to do is get rid of this multiplied 4 in the beginning. And to do that, I divide both sides of my equation by 4. These 4's cancel, leaving me with x squared minus x minus 2 equals 0. And from this point, I'm going to use my x method. Okay, remember, with the x method, on the top of the x we have multiplication, and on the bottom we have addition. Now remember, on the top we take our a value, which is 1, and in this case multiply it by c, which is negative 2. 1 times negative 2 is negative 2. On the bottom, we write our b value. Well, our b value here is negative 1. And then we look for factors of our AC. Well, a times c is negative 2. We want factors of negative 2 that will add up to negative 1. The only two factors of 2 that we have are 2 and 1. And when AC is negative and b is negative, the larger factor is negative. So we bring our factors over here. We got negative 2, positive 1. And then we write our two factors in two parentheses. They start with x, and they end with the two factors we just found. After we write our factors in, remember we divide both of them by a, and a in this case is 1. Negative 2 divided by 1 is still negative 2. 1 divided by 1 is still 1. And to solve this equation, we need to take each one of these factors and set them equal to 0. So x minus 2 equals 0. Solve it. Add 2 on both sides. One of our answers is positive 2. Take the other equation. X plus 1 equals 0. Solve it. Subtract 1 on each side. Our other answer is x equals negative 1. Now, you could have done the same problem using the quadratic formula. It's just up to you which one you like. All right, let's move to the back. Okay, the back's part 2. It says solve the following quadratic word problems. Remember to use only reasonable solutions. If it's looking for time, time is positive. There are no time machines. Okay, we can't have any negative time. So if you look at number 9, it says Erin and her friend launch a rocket vertically into the air. The height of the rocket after t seconds is given by the equation. This is the same one we've looked at all week. Negative 16 times t squared plus v times t plus h. Where s is the starting height. They want to find out how high they can expect the rocket to go and how long it will be in the air. Okay? If the rocket has an initial velocity of 80 feet per second and it's shot from initial height of 110 feet, identify the standard form of the function. All that wants you to do is write the equation. Remember, standard form is ax squared plus bx plus c. So, our equation here would be h of t equals negative 16 t squared. The next thing we see is v times t. So we're just going to replace our v, in this case, with 80. because it says our initial velocity is 80 feet per second. Then we see plus h. Well, our height here is 110 feet because in the example it says a height of 110 feet. That's all 9a wants is the equation. 9b is where you solve the equation because it says how long does it take for the rocket to return to the ground. The ground would be the x-intercept, which is a solution. So if we're looking at this, we would identify A is negative 16, B is 80, and C is 110. And then we would just plug it into our quadratic formula. Now I wrote T because we're looking for time, and that reminds me I need a positive answer only. Okay, so my time here is equal to negative B, or opposite B. So I'll start with negative 80 plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Now pause and go ahead and punch it in your calculator. Remember, you only want the positive answer. Now the positive answer here for time is approximately 6.12 seconds. The other answer I believe you got was negative 1.12, and obviously you wouldn't have any negative time. All right, let's move to number 10. When you look at number 10, it says a cannonball was fired from a cannon on a ship and landed in the water, so obviously it makes a parabola. Its height is described by the function h of t equals negative 16t squared plus 76t plus 20. T is the time in seconds since the cannon was fired. Determine how long it took for the rocket, or the cannonball in this case, to return or hit the water. Okay, so again, we're going to solve. And to solve, we need to know what A, B, and C are. A is negative 16, B is 76, and C is 20. I can see those from the equation. And then again, I'm looking for time, so it's got to be positive, so I'm going to plug it in my quadratic formula. Opposite B is negative 76, plus or minus the square root of B squared minus 4 times A times C. Again, when you put that A value in, make sure that you're putting in negative 16 all over 2 times A. Again, pause it, plug it in, make sure you have the positive answer. All right, for this one, the positive answer for time should be 5 seconds. All right, let's move to number 11. All right, on number 11, the height of a baseball that's been hit can be described by the expression. And again, it's the same one, negative 16t squared plus v times t plus h, where t is time in seconds, v is the initial velocity, h is the initial height. A says write an expression for the height of a baseball at a time t when the initial velocity is 65 feet per second and the initial height is 4. What that's saying is the v value is 65 and the h value is 4. So it wants us to write a new equation. So that one had f of t, so let's go f of t equals negative 16 t squared plus, instead of v, I'm going to put 65 because that's the velocity it gave me. 65 times t plus, instead of h, I'm going to put 4 for my height because that's the height it gave me. And then B says, how long did it take the baseball to hit the ground? And you see the hint, it says solve for t. So again, like we've done on the last two, label A, B, and C. A is negative 16. B right here is 65. And C is 4. Again, we want only the positive answer. So we're solving for t, or x, whatever you want to call it. Our time is equal to opposite B. So we got negative 65 plus or minus square root of b squared minus 4 times a times c all over 2 times a. Again, pause it, punch it in. You only want the positive result. And the answer you should get for this one is 4.12 seconds. If you have any questions, please make sure you ask them before class is over.